Hi everyone, let's talk about how many different kinds of data that we can handle within BangDB. BangDB can handle multiple kinds of data, and we can define what kind of a data you want to ingest by using a particular kind of a table. So if you create a new table, let's just give it a name, table 1. And if you expand the table type, you will see that there are multiple kinds of a table that is listed here. In any particular scenario or any application, we have many different kinds of data that we want to ingest into the database. We will have certain kind of a data which is opaque in nature, where we cannot see inside the value. We will have a data which is semi-structured or structured like JSON doc, and we will need to store that. So we can do little bit more here when it comes to little bit of a structured data. Then we have some of the data where the value size is always fixed. For example, long type or int type or short type. Then we are talking about primitive data types. We have scenarios where the size of object or the files are very, very large. Then we are also talking about storing the triples in a particular way so that we can create a graph and then we can travel on that graph. Hence, any simple application, we are talking about multiple kinds of data, and we need to store all these data into the single database. Typically, what happens with many other databases is that we need to bend backwards and aligned with a particular structure that database supports. So for example, if we are just talking about a key value store, then everything has to be opaque in nature. If we are talking about a document store, then everything must be treated like a document. And if we are talking about a column family store, everything must be treated like column family and so on. But the fact of reality is that we deal with multiple kinds of data and we need to store them without much friction. Hence, BangDB supports multiple kinds of table. The first one is normal table, which is pretty much like a key value store you can think of. So where the value is opaque in nature. And since it is opaque in nature, so we cannot index any data which is there within the value. The second one is white table. White table is akin to document store. So here I can store JSON document. And since JSON document is structured in nature, so now I can create multiple indexes. Those indexes could be secondary index, be nested index, could be composite index, could be reverse index, could be geo index. Many different kind of indexes are supported here. When we want to store, let's say, fixed size value, then we will go with the primitive table type. The primitive table int, long and string suggests the type of the key. If the key is int, we'll go with this. Key is long, we'll go with this. Key is string, then we'll go with this. Value is always going to be a fixed size. Then there is a large table, and for large table, we would like to store big files that could run into several tens and hundreds of GBs. There is no theoretical limit there. Or you can also store arbitrary objects. For graph, we have a different kind of graph processing framework itself, and we'll discuss about it in subsequent video. Now let's say I want to create a white table, which means I want to store JSON document. Now what is the key type? So key type could be string, composite and long. String is akin to variable key type, where the size of the key is variable. The composite is again string in nature, but it is of composite nature. And long is where the key is fixed, 8 byte always. So if we select string or composite, we need to define the key size. Typically and ideally, the key size should be as less as possible because it really improves the performance and efficiency of database. So ideal key size is anything between 8 to 48 bytes, but we can go beyond that also. Theoretical limit is somewhere around 8 KB. So we can have a key of 8 KB as well, but we should not do that. We should always have a key size as low as possible. And this is only true if we select string. If suppose we select long, then key size disappear because we know that for long it is always 8 times. So let's create a string of 24 bytes. Now pk index type suggests that how we want to arrange the primary key. Primary key can be arranged in two different ways, which is one is hash, the other one is B tree. The hash is actually extensible star link hash, and B tree is B star link tree. With ext hash or hash, we cannot do scan query. We cannot run a range scan query because they are stored arbitrarily in using some hash value of the key. But with B tree, we can run scan or range query. So let's select the B tree. The sort method suggests that how are we going to sort the primary key. So sort direction, again, we have two kinds. One is ascending and descending. Let's go with ascending. Now DB type, we see that there is an in-memory only, then in-memory, persist, and then persist only. Persist only is not supported right now. Persist only means that the data will not reside in memory at all, and it will always be on the disk. This is very less efficient. For certain cases it may make sense, but not for the purposes of this SaaS version of the BangDB. So we have in-memory and in-memory persist. In-memory means that everything is going to be inside the memory. It is not going to be backed by the log file. It is also not going to be backed by any disk file until you want to flush the data. But in-memory persist means that we are going to write log files. We are going to be backing the data on the disk, and this is a lot more preferable. So we'll go with in-memory persist. Further, we have 4 more options here. We see that there is a sliding window. If suppose we want to make sure that this table is sliding for a particular time period, let's say if we click that, then we need to define what is the TTL second. It could be 1 day, 1 minute, 1 hour, anything, any arbitrary number. Allow duplicate is for the primary key. Now, in many cases, the primary key should be always unique, but there are some cases where we would like primary key also to be duplicate. So to do that, we can click this duplicate button. The reverse indexing is important if suppose we want to reverse index the value, the data which we are going to store in the table, then we should click this one. And version is for maintaining the different version or different copies of the data. So we'll let's say we enable the reverse index and we allow duplicate, and then we create the table. And now we see that the table 1 is created, and we can go and check the details, and we see that whatever we selected for this table configuration, those details are showing up. So next video we will see how to run query on the table, how to insert data and select data from the table. Thank you.